Hi guys, thank you for joining. Today we will work through the Mathematics Paper 1, May to June, Question 2. In the previous video we worked with Question 1. Now let's work with the sequences. So let's begin. 2.1. The first term of an arithmetic sequence. As soon as you see this, you know you're dealing with Tn is equal to a plus open brackets n minus 1 multiplied by a difference, right? So we know our first term is equal to minus 1. Your seventh term, Tn, T7 is equal to 35. And you know your n is equal to 7, your seventh term. Now, in 2.1.1, they want to know the common difference of the sequence. All we have to do is substitute these values into the arithmetic equation. So 35 is equal to minus 1 plus open brackets 7 minus 1 multiplied by a difference, which is what we need to find out. Take the minus 1 to the other side, change the sign, we get 36. 7 minus 1 is 6, and therefore your difference is equal to 6, right? Next is 2.1.2. The number of terms in the sequence. Notice the number of the terms, so we know they are speaking of n. If the last term of the sequence is 473, so Tn is equal to 473, and we don't know this value n. That is what we need to find out. So let's substitute what we have into our equation. So 473 is equal to minus 1 plus n minus 1 multiplied by the difference. And I'm going to take the 1 to the other side. So we have 474, 6n minus 6. Multiply that out. And now we have 480 is equal to 6n. Therefore, n is equal to 80. Right? I put that into the calculator now. Next is 2.1.3. Right? The sum of the first 40 terms in this sequence. This is fully substitution. If we go to the information sheet, we just use that equation, right? Sn is equal to n all over 2 square brackets 2a plus open brackets n minus 1 multiplied by a difference. And now sum of the 40 terms is 40 all over 2 open brackets 2 multiplied by minus 1 plus open brackets 40 minus 1 multiplied by a difference, which is 6. And this will equal to 20 multiplied by minus 2 plus 39 multiplied by 6. And that you can put into a calculator. For 640. Okay, that's it. So you should be getting these full 8 marks. Let's move on to question 2.2. Sorry, this is about 7 marks. They are quite stingy here. I'm going to move this out of the way. think this is going to need a lot of space. Let's see why. So 2.2. We know the quadratic. It's a quadratic pattern. So immediately we know we have to write down that sequence again and find the first difference, which will be minus 22. Second difference, minus 18. Third difference, I don't know this one. I need to put it to the calculator. Minus 14. Second difference is 4. 4 again. Right. Notice we're taking 53 minus 75, and that will equal to minus 22. Here we're taking 35 minus 53, and that will equal to minus 18. Right? That's how we're ending up with the negative values. Notice your sign is very important. In the second difference, it's minus 18 minus minus 22. Let me show you that. And that's how we end up with positive 2. I mean positive 4. The other term is minus 14 minus minus 18. And that's how we end up with positive 4. So that was quite important there. Now they want the fifth term of the number pattern, right? Let's put in some placeholders, I would call them. Right. So we need this value. Let's call it x. We know that x minus minus 14 should give us 4. X is therefore simply minus 10. Right? Now we need to know t5. t5 minus 21 should give us minus 10. And we see that your t5 is going to be positive 11. Therefore, t5 is 11. Let's move on to 2.2.2. Determine the nth term of the number pattern. Here for the quadratic pattern, your nth term is equal to an squared plus bn plus c. Right? We need to use this portion for 2.2.2. But watch closely. The first difference. That's my WhatsApp messages. And you have your second difference. Your second difference is equal to 2a. Your first difference is equal to 3a plus b. Alright? So 2a is equal to 4. Therefore a is equal to 2. Then 3a plus b is equal to minus 22. We know the value of a calculated above. And we see that b will equal to minus 28. Now we still need to find the value of c. So we need 2 points here. We need tn and you need n. I normally take the first term because it's the easiest. So term 1, term 2, term 3, term 4, term 5. I would take the first term. And For that, n is equal to 1 and t1 is equal to 75. So now it becomes simple substitution, right? Tn is equal to 2n squared minus 28n plus c. Now let's substitute in these values. 75 is equal to 2 open brackets 1 squared minus 28 open brackets 1 plus c. So 75 is equal to 2 minus 28 plus c, and c is equal to 101. And now we can write the final nth term, which is equal to 2n squared minus 28n plus 101. Now we're getting to the beautiful questions, right? Determine the maximum value of the following number pattern. Right? We know we are dealing with quadratic equations, so we know it's going to be a parabolic function or quadratic function. And when they ask for a maximum value, we know the curve is going to be inverted, and we are going to get a maximum value, right? But we cannot calculate this the way we did previously, right? We can, but it will take a lot of time, and this is only 4 marks. So using this method is quite strenuous, but you will get your full marks if you do that method. Here we need to find a sequence or a pattern, alright? Firstly, I see 53 is common, 21 is common, so I think they are dividing by 5. Let's see. Let's divide this entire equation by 5 and see what we get. Divide that by 5, divide by 5, divide that by 5. 75 divided by 5 is positive 15. 53 divided by 5, that's a decimal. 35 divided by 5, that is 7. 21 divided by 5, that's a decimal. And we keep that as is. Right? So, we observe that this sequence when divided by 5 is equal to that, which is very similar to what we have in 2.2.3. However, this is all the terms are negative, so they have multiplied it, the entire sequence, by negative 1. Immediately they have done two things to the sequence. So 2.2.3 is more clearer now. They have divided it by they have divided by 5, and they have multiplied by -1. Two things they've done. So these two things we can implement to our nth term we've calculated above. So we take Tn is equal to 2 all over 5n squared minus 28 all over 5 plus 101. Here we've only divided by 5. Now we need to multiply the entire thing by -1. That's now a positive. See? Let me explain while I'm writing it. -1 multiplied by 2 all over 5 is -2 all over 5 n squared. -1 multiplied by -28 all over 5 is positive 28 all over 5 n. See, I've missed plus 101 minus 1 is minus 101. And that is your new nth term sequence, right? Now they want to know the maximum value. Let's just sketch down a Cartesian plane. Maximum value somewhere there. We know the x value of the turning point is equal to x is equal to minus b all over 2a. In this case, it's not x, it's n. Right? Normally, our quadratic equations will be written as ax squared plus bx plus c, but this is in the form of an squared plus ban plus c. So therefore we have the n there. So n is equal to minus b, which is 28 over 5 all over 2a minus 2 over 5. Right? And n will equal to, I need to put that into the calculator. N is equal to 7. Now we need to find your 7th term. So we need to substitute 7 into the equation. Plus 28 all over 5 multiplied by 7 minus 101. And your 7th term, or your maximum term of the sequence, will be, let me put this to the calculator. Something is not right there. I think I'm not putting it correctly into the calculator. I'm getting minus 407 all over 5. I see the problem. We forgot to divide it by 5. We divided everything by 5 except the c value. That is our mistake there. So now if we correct that, I think this is more representative. This is the correct solution. And that's your 4 marks. Okay, thank you for watching. In the next video we will work with question 3.